Elon Musk has just attached a staggering $10 trillion revenue target to Tesla's Optimus robot. This figure sounds almost like something from a science fiction novel, not a corporate earnings call. However, Musk's track record of exceeding expectations is hard to deny, and when he sets a specific price target, as he has done several times before, Tesla often reaches it. But even with his history of innovation, the $10 trillion figure raises some eyebrows. The math doesn't seem to add up, considering the number of robots Tesla would need to sell to hit that target. So what's the missing piece of the puzzle? What secret strategy might Musk be hiding that could unlock this extraordinary level of value? Let's break down the numbers, projections, and potential game changers that could make this ambitious dream a reality. Tesla has laid out a roadmap for the Optimus Humanoid robot, which is still in the early stages of mass production. Musk initially predicted limited production of around 1,000 robots by 2025, with these units being deployed to work in Tesla's own factories. But during the latest investor call, the target has been revised to 10,000 Optimus robots by the end of this year. Going forward, Tesla plans to scale production dramatically, targeting 100,000 robots by 2026, 1 million by 2027, and so on. 2026 will be a major milestone for Optimus, with Tesla planning to make the first customer deliveries. Musk hinted that the robots will likely be sent to companies first, in line with their initial deployment within Tesla's own factories. This could be the beginning of the incredible $10 trillion revenue stream that Musk is talking about. In a recent conference call, Musk also took a subtle jab at OpenAI, a major AI competitor, mentioning that with $10 trillion in revenue, investing $500 billion into AI would actually be a great deal. This was a reference to OpenAI's plans to build $500 billion in AI infrastructure over the next few years. However, Musk pointed out that OpenAI doesn't currently have the funds to do this. If Tesla truly reaches $10 trillion in revenue, that $500 billion would be a drop in the bucket. So, while the $10 trillion target might seem outlandish at first glance, Musk's long-term strategy could hold the key to turning this bold vision into a reality. The math behind the $10 trillion target, why it might be unrealistic. Let's dive into why reaching a $10 trillion revenue goal with Optimus robots doesn't seem to add up. First, let's assume that each Optimus robot costs about $20,000 at a large scale. This seems reasonable when you consider Tesla vehicles, which are priced around $30,000 and contain much larger 50 kilowatt-hour battery packs, the most expensive component of the car. The Optimus robot would require far fewer battery cells, say just 3 kilowatt-hours. Plus, humanoid robots use less material than cars, but still include similar components like motors, batteries, and chips. In fact, $20,000 might even be on the higher end, given mass production. But let's stick with this assumption for now. Now, if we divide Musk's ambitious $10 trillion target by $20,000, we get 500 million robots. That means, to hit the $10 trillion revenue goal, Tesla would need to produce 500 million robots every year. Looking at Tesla's own projections, they plan to produce 10,000 robots by the end of this year, 100,000 by 2026, and 1 million by 2027. At this rate, Tesla would hit 500 million units per year by 2030, which sounds incredibly ambitious. While this might be theoretically possible with some extraordinary work, it's still a huge stretch. Musk himself isn't even sure Tesla can hit the 10,000 units this year, and multiplying production by 10 every year is a tough goal. Even though Tesla has ramped up vehicle production quickly, it's nowhere near 10 times growth annually, maybe over the course of 10 years, but not one. It's also worth noting that Optimus is smaller and potentially cheaper to produce than a car. But let's look at the iPhone as a comparison, a device that's much smaller, technically easier to produce, and less expensive. Even then, Apple has only reached around 230 million units per year at its peak. That brings us to another question. Would there even be enough demand for 500 million robots per year? And at $20,000 apiece, that's a big ask. If the price of Optimus robots were to drop, Tesla would need to produce even more units to reach the $10 trillion goal. This would be an enormous challenge, and it seems like a stretch for Tesla to hit that number, even by 2030. It's odd that Musk would bring up such a high revenue target now, considering how difficult it would be to achieve. So while the idea of reaching $10 trillion in revenue with Optimus robots is intriguing, it doesn't seem likely that Tesla's actual plans involve hitting that target this way. The robot leasing model. Unlocking trillion-dollar potential. Instead of seeing Optimus as a one-time product sale, it's far more likely and profitable to think of it as a rental service. The robot is designed to handle tasks that humans either don't want to do or that are too dangerous. Ultimately, Optimus could perform any task a human can, while significantly boosting human productivity by having a team of robots available on demand. In terms of revenue, Optimus shouldn't be viewed as a single hardware sale, but rather as a recurring software subscription. If Optimus can perform tasks that rival human capabilities in the next few years, its value will increase, especially when you consider the cost savings. Unlike humans, Optimus won't need breaks, won't lose focus, and won't require health benefits or retirement savings. It would just need regular maintenance, saving businesses a ton of money. Imagine a robot that can perform skilled human-level work worth $50 an hour without the additional expenses that a human worker typically incurs. This makes Optimus especially attractive to companies, as it can make their operations more efficient, productive, and even safer. Musk's comment about sending Optimus to companies first makes sense because these businesses can afford the robots, and they'll see a return on their investment through increased productivity and cost savings. Let's break it down. If an Optimus robot worked 20 hours a day and operated 350 days a year, it could generate $350,000 in revenue annually. Assuming Tesla covers the cost of hardware and maintenance, which would be small compared to the revenue generated, the math starts to look more achievable. With $350,000 per robot per year, Tesla would only need to produce 29 million robots, not the 500 million originally suggested. That's a one-time total, and with the software rental model in place, it becomes sustainable revenue over time. If Tesla follows its expected growth trajectory, they could hit this target as early as 2029, with far fewer robots needed to achieve the goal. Instead of 100 million robots or 500 million by 2030, they'd only need to produce about 17.4 million robots in 2029 to meet the $10 trillion revenue target. This approach dramatically reduces the number of robots required while still achieving the ambitious financial goal a year earlier. Tesla's $160 trillion market cap, the potential of Optimus. Let's take a moment to imagine Tesla's market cap hitting a mind-boggling $160 trillion based on the $10 trillion revenue projection for Optimus. Assuming 80% of that revenue is software, that would leave Tesla with $8 trillion in profit. Using a 20x price-to-earnings (PE) ratio, this results in a $160 trillion market cap, which is absolutely insane. Of course, there are a lot of variables at play. Tesla may not reach that production level, and the price of humanoid robots could drop as they become more common and widely available. But on the flip side, by 2030, if Tesla adds another 29 million robots to its fleet, it could double its incremental revenue. No matter how you look at it, these numbers are massive compared to the current market caps of major companies, and the projections are only 5 years out. In fact, 29 million robots doesn't seem that outrageous when you consider companies like Amazon. Amazon employs 1.5 million workers and already has around 750,000 robots. It's possible that many of these robots will need upgrades soon, making Tesla's Optimus an even more attractive option. Tesla's secret weapon: self-replicating robots. An intriguing point Elon Musk made in a recent conference call was his plan for Optimus. Musk mentioned that he wants to train Optimus to perform enough tasks to match the output of other Optimus robots. While this might sound like a slip of the tongue, it's worth considering. We know from previous Tesla events that Optimus is being trained to build other Optimus robots, so there's a possibility that Tesla has set up a production line where Optimus robots build other Optimus robots. This would be a groundbreaking approach, having robots compete to build more robots faster than traditional production lines. If Optimus robots become experts at building themselves, they could also become experts at repairing each other. Imagine if a robot breaks down at a company Tesla leases it to. Optimus could potentially repair itself, diagnose its own issues, or even call on another Optimus robot for help. This self-sustaining model would be incredibly valuable for Tesla, as it would mean lower operational costs and increased efficiency. That said, it's important to note that having Optimus manually build other robots might be just as inefficient as having humans do it. Musk has always said that the factory itself is the product. So, for Tesla to scale effectively, Optimus robots would also need to specialize in building the production lines for other Optimus robots. This focus would be key to Tesla's The Future of Manufacturing, how Optimus could revolutionize the economy. An ASIC is a specialized chip designed to perform a single task quickly and efficiently, while Optimus is a more generalized robot, like a Swiss Army knife. But when it comes to mass production, it's much more effective to build dedicated production lines specifically designed to produce robot parts. The goal for Tesla is for Optimus to specialize in both, learning to manually build, test, diagnose, and troubleshoot individual robots, which will be incredibly valuable for maintenance and repairs, especially when managing a large fleet of Optimus robots in the future. However, to truly scale, Optimus will need to learn how to build efficient factories for itself. As Elon Musk has said, the factory is the product. Tesla is already working on developing these production lines, and the key here is that Optimus could have a compounding effect. For example, if 1,000 Optimus robots can build a factory capable of producing 10,000 robots, those 10,000 robots could then build 10 factories, each producing another 10,000 robots. In turn, this means 100,000 robots would be able to build factories themselves, creating a massive self-replicating manufacturing system. It's similar to cell replication in biology, but applied to manufacturing. This could enable Tesla to scale up production much faster than expected, helping the company reach its moonshot goal of $1 trillion in yearly revenue and beyond. So, what do you think? Will Optimus be capable of building other Optimus robots? And when do you think Tesla could hit Elon Musk's target of $10 trillion in revenue from Optimus? Don't forget to check out my previous video, like this one, and subscribe. Your support means the world to us, and a big shout out to all our patrons for helping us keep the channel going. Thank you so much for watching.